Yo, 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 we're going to be looking at sections 5.2 and 5.4 today. And one of the things we're looking at here is this word you might see a lot, equidistant. So this is just talking about an equal distance between things. So that in this example here, we have C and A and C and B are equidistant. So C is equidistant between A and B. So those have equal or congruent lengths. Same thing with D here. We see these little ticks. That lets us know that D is equidistant between A and B. We can also call D a midpoint. We're looking at perpendicular bisectors. All right, and so this does two things. Perpendicular, we already know it creates a right angle. And bisector is saying that it splits the next side into two equal parts, or it intersects with the midpoint of the opposite side. So if we look, we create this line PM, and it is a perpendicular bisector. That lets us know a right angle is created. That lets us know that we have equal distances between AM and BM. And it also lets us know that the distance from P to A and P to B is also equal. So we'll look at lots of examples of those things. Same thing as what it's doing. We're doing that exact theorem here. So we see that we have a right angle. We see have the distances between here are equal, which means BC is congruent to DC, and we get our answer. So no calculating there. This next one, we're going to be using that same theorem. So we have a right angle here. We have equal distance here between JB and K to B. Therefore, we can set these equal to each other and solve. Here we have a drawing here. I just made it evident that we're looking at triangles, so it just makes sense that we're also looking at triangles. So we can say that these things are equidistant from each other. So same thing here. The distance from 14th Street to Adams School and Union Square is equal, because if we look at the distance here and we drop down a perpendicular bisector. Here we're looking at very similar to what we looked at. This is called an angle bisector, and it does the same thing. All right, so it creates angles that are equal. So the same way in that we can divide the side length into equal parts, we can divide an angle into equal parts, and this is called an angle bisector. And so same thing here, we're looking at this angle. Because we have all of these conditions here between the right angle and equal sides, then we can set these angles equal to each other and solve. And looking back once again at that same theorem, the only thing that's different here is once we set these equal to each other and we get the answer, we also must plug it in. And these must be the same, because that's what we're saying here. We're saying that these sides are equal. Once again, we're setting these equal to each other, finding our y value. Here, watch out, we are setting them equal to each other to get x, but it's not asking us for x. It is asking us for the distance of TW, so we need to plug that back in. And then here we're getting into 5.4. We're looking at medians. Median is nothing more than a line, and then it has a vertex is where it starts. So here would be where a vertex is. And then where it ends, it is ending at the midpoint of the opposite side, which is to say that it is bisecting this other side into two equal parts. And we're also looking at the centroid, that relationship that it has. And so when we have three medians intersecting, their intersection point in the middle here is a centroid, and that centroid has a special relationship with the lengths. And so F to H, if we look at this distance, C to H is 1/3 of that, and F to C is twice C to H, or F to C is 2/3 F to H. And so we'll do some examples of these here. And so here we're looking at, we know that this is the centroid K. We're given A to K is 11, and it's asking us for K to P. So we know that K to P is 1/3 of A to P, but that doesn't really come into play here. We just know that this part here is half of A to K, so we simply have to divide by 2. In this next section, we're given D to M, the total distance, and so we can do both thirds. The smaller part is 1/3, so I divide by 3 to get 13. And I know that this part is twice the smaller part, so I multiply that by 2 to get the second one. Here we're looking at the difference. Altitude is when we start at a vertex and we create a right angle. A median is where we start, and so B to Q this would be a median. A to P would also be a median, but the example we have is an altitude.